Okay, to calculate grade point average, the first thing we have to realize is that every class is not worth the same amount of hours. So for example, in biology, a 4-hour course, whatever you get in there counts more than what, let's say, the PE 1-hour course would count. So the tendency for a lot of people when they calculate grade point is just to say that a C is worth T2 if we were over here, and then a B is worth 3 and a C is worth 2, and then just get whatever those are and divide by the number of courses. That doesn't take into account the fact that the courses are weighted with different hours. So what I've done over here is just write down the last number in each course number here at our university. That is the number of hours for which the class counts. So 4, 3, 3, 3, 2, 1. And then for the grade point, I'm just writing down what a value is for a C, an A, or whatever. A C is worth 2 points. A B is worth 3. A C is worth 2. An A is worth 4. A B is worth 3. And an A is worth 4. And so that's how many points you get per hour. And these are the number of hours. So for each class, you just take the product of those. So for the biology class, you earned 8 grade points. And for the English class, 9 grade points. And so on. And when I add that up, I get, let's see here, 45. And the number of hours, you have to add those up. That's 16. So the GPA is going to equal 45 divided by 16. And that is 2.81. And so on our thing here, that's option B. Okay. And the next one here, we have a bunch of stuff it's talking about there, but the question is just looking at the data and the graph here, which of the following is true? And because of this outlier, it's going to pull the mean out away from the data set, so the median is still going to remain in the middle. So the mean will be larger than the median. So let me bring this back over here, and if I can. So anytime if you have a distribution that looks like that, then the mean and the median and the mode are all going to be about the same. Mainly. If you have something that is skewed to the right, or something that has an outlier, an extreme value over here, the mean will be greater than the median. And if you have something the other way, especially if there's an outlier over here, then you're going to have the mean less than the median. These extreme values or skew will draw the mean away from the middle of the distribution, away from the median, and the median will still stay in the middle of the data set. What percent of students are studying 6 or more hours for the midterm? Well, in this one, you really, first of all, just have to do some counting. And so we can just look at this. We have 25 students, and there's 2 ways you can do this. It's this 6 or more. That's going to start here and go up. And I could just add 6 plus 3 is 9, plus 2 is 11, plus 1 is 12, plus 1 is 13. So it's going to be 13 out of 25, and that's going to be 52. The other thing you could have done is just said there, out of 25, there's 3 in this class and 9 in that, and that's 12, so at least 13 over there. In either case, it's 13 out of 25 is 0.52. Which of the following yields a cluster random sample? Obviously, it wouldn't be volunteers. Listing the individuals by ethnic group and choosing a proportion within each ethnic group at random, that would be stratified random sampling. Number all of them in a sampling frame and then using random number. That's simple random sampling. Now this one, randomly select schools. So we're not getting we're just going to randomly select the whole school. Maybe we get 10 schools in the state of Arkansas, and then sample everyone with each of those selected schools. It's just really one school. It's not a school. But there we go. And I think I'll stop here on